All right. Welcome back to MSDOSX. Today we are talking about MapKit and core location, which allow you to make your app really location aware and know where the user is and draw maps to show the user where they is and all that kind of good stuff. So to begin, we're going to start with core location, which is how we're going to set a frameworks for getting the user's the device's current location. And the features will vary somewhat dependent on the hardware. Some pieces of hardware have a compass, some don't. Some have more accurate GPS depending on whether or not it's Wi-Fi assisted or not. But the basic idea is that core location is a set of frameworks that allow you to query the device for where it currently is in the world, and you can also register for notifications for any time the location changes, so that way you can kind of let core location in the background listen for changes to the location and send you a notification when it's reached some threshold of how far the distance has changed, which you can set. And one other really cool feature, and I think this is since iOS 5 possibly, maybe it's earlier, but you can also monitor not just a particular distance, but you can also create a region and geofence that region. And then when the user enters or leaves that region, you'll get a notification saying they entered or left that region. Is that since iOS 5? For example, the Reminders app that shipped with iOS 5 is a great example of using geofencing, where you can tag a location and automatically post a reminder when you enter or leave that location. And so there's an API for that. Okay, so let's talk about getting the device's location. So there are two basic ways to get the device's current location. There is what they call the standard location service, which is this fully configurable, totally general purpose system for getting the device's location and getting notifications for changes to that location. There's a lot of parameters that you can change about that. You can update, how you can set the granularity of how precise you want down to, I don't know how precise it is, but you can say, okay, I only want on the order of a kilometer or 10 kilometers or however precise you want. And you can also specify how often you want to get notifications. So if the user's location changes by half a kilometer, then let me know. Things like that. So the standard location service is really very customizable. You can set all the parameters that you want. There's also what they call the significant change location service. One downside to the standard location service is that it's rather expensive because GPS getting your location requires the device to turn on a lot of its radios, and using those radios is pretty expensive. So the standard location service, when used for a long period of time, will have a significant drain on the battery. The significant change location service, on the other hand, is written in such a way that it uses the radios as minimally as possible. You don't have quite the same level of granularity and control as you do with a standard service, but the significant change one basically works by detecting when the cell tower changes, and then that's when it decides, okay, now's a good time to reevaluate the location. So if you don't need super fine granularity in your location, the significant change is probably what you want. So like I said, getting location data is very expensive on the battery, and whenever possible, Apple recommends to use the significant change location service, so that way you can save the user from draining your battery because your application has gone awry. And that's especially important now that applications can be backgrounded, because if your application is in the background continuing to run the location service, and that's one kind of neat thing about core location, is that can actually run in the background while the user is in some other application. If you have the standard location service running, then even if they're not actually using your application, you're still draining battery, and so that's something we want to avoid. Okay, so how do we determine if your device can get location services? Well, there's a pretty simple Boolean method on CL Location Manager that says, are location services enabled? And it just returns true or false if they are. And there are a number of cases when location services would not be available. The user has the option to totally disable location services in settings. They can just turn them off entirely. It means no application anywhere on iOS has access to the device's location. iOS also has the ability for you to disable access to the location services on an app-by-app basis. So the user may have disabled it for your application. And finally, the device might be in, say, airplane mode, where all the radios are turned off, but the device is still running, but you don't have access to the radios. So if you try to start location services even if you get a no back from their enabled. You'll get that prompt, that your application will show that prompt asking the user to confirm whether or not they want that application to show services. And if they click deny, then you're not going to get any data. But if they say confirm, then it will unlock that. I imagine if you're in airplane mode, it won't turn on the radio because that kind of would defeat the purpose of airplane mode. But so if they have them disabled, that will re-enable them. But usually, if the user has them disabled, they have a good reason for it, so they probably won't enable it for you. Okay, so here is some code from Apple of how to start the standard location service. So suppose we have some instance variable in our class called location manager of type CL location manager, just to make sure that they had this little logic check to make sure we only make one. There's no need to make more than one. Then you set the delegate for that location manager to be the one that wants to receive notifications for this location change. There is a desired accuracy property that you can set for how accurate you are, and there's several pound defines for these different accuracy levels. We've chosen here the kilometer accuracy level. And then there is a distance filter for how far the user needs to move before a new location change event is fired. In this case, this is in units of meters, so in this case that's half a kilometer. And then you just tell the location manager, start updating the location. And as location data comes in, it will call the delegate methods, and I'll get to those in a second.
Does higher accuracy imply like more battery usage?
Generally speaking, the more precise you want, the more radios need to get turned on, and that means that it's going to cost more on the battery. Okay. Yeah, I think with some of the pretty less accurate ones, it can do pretty good just based on the cell tower, and so that doesn't require much extra battery because that radio is pretty much always on. But yeah, some of the other ones, especially if you want to use like Wi-Fi, if it'll start using Wi-Fi assisted, then those will become more expensive. Okay, and similarly, the significant change updates service is a little bit simpler because again, you can't control the parameters of it. So you just set the delegate and then say start monitoring significant location changes, which will basically runs this, but with some not so expensive default values. And then it will just continue to call the same delegate methods that the other location manager calls. Okay, so what happens when we get what gets called when we get location data? It's this. We've done that 3 times in a row now. When I display it, the first line is tabbed in 3 spaces, even though it wasn't on my slides. Anyway, so location manager did update to location from location. Will get called every time a new update of the user's location happens. It passes in the manager that sent it, the new location, and the last location that was reported by core location. So that way you can work out how fast they're moving if you want. One neat thing about core location's location objects is that they actually have this parameter called, they call it course, where they can actually determine, and I'll get to this a little bit when I talk about headings, but it can actually determine how fast they're moving based on just recent changes. Okay, region monitoring allows you to define a circular region. So basically, you pick a point that you want to be the center of your circle, define the radius of that, and that defines a region that will get monitored. And you'll get a message when you leave or enter that region. Okay. Again, just to kind of really hit the nail home, it's whenever you're not using location service. These are tips straight from Apple. I don't think I even paraphrase these. I think these are exact text quotations from it. But they recommend, first of all, if you don't need location services, turn them off. Just immediately turn them off because that will save you a lot of battery in the long run. Again, whenever you can, use the significant change service so that way you use fewer of the radios, use less power. If you need more granularity, then at the very least, use the least accurate resolution that you need, so that way you can use the least amount of battery power. And then they have this kind of funny one that if you keep waiting for accuracy to get better and better and better, and it doesn't seem to be getting any better, then stop asking for it, because it's probably not going to get any better. It might mean that they're in between cell towers, and it's kind of switching between which one they're in, or they have really bad reception or something, or they're inside, which would make a big difference. Okay, so one other neat thing that core location provides, assuming that the device has a compass, is it allows you to get the heading of the device, which is which direction it's pointing relative to the North Pole. So any device with a magnetometer can do this. it will give, by default, it will give you the direction of magnetic north. If you want true north values, then you also have to know the device's location, so that way you can correct for the difference between true north and magnetic north. Generally speaking, if you're not at the poles, it's close enough. But if you are the closer you get to the poles, the more the difference is going to be noticeable. So if you have apps that you know are going to be run in Canada or at Antarctica, then I guess you want to make sure that you get it accurate, so you would turn on locations. But if it's really important that you get true north, then you want to turn on the locations. So that way you can it will automatically correct for that. But if you don't have the location enabled, then it will just give you magnetic north directions. Which, of course, like any magnetometer, can be confused by local magnetic field. So if you're near a big magnet, it's obviously going to get fooled by that. But generally speaking, if you're not near any big magnets, you'll get the Earth's magnetic field. And like with location services, there's a really simple method for asking, can I get the heading? It's heading available. Returns yes or no, and tells you whether or not the device supports the heading. Which is nice, because then this abstracts away whether or not the actual hardware actually has a magnetometer. It just tells you if the service is available. So how do we start heading updates? Again, very much like before, in this case we're going to start the location service so that way we can get true north readings. And then, assuming that that we can actually get headings, we set a heading filter, which, like the distance filter before, which tells us how far we have to go before we get a location update. Heading filter is how many degrees we have to turn before we get a heading update, and then we just say start updating headings. And as we get updates, oh boy, this method will get called. So it passes in the location manager that sent it and a heading object, so that way you can query what the device's heading is at that time. Okay, one other neat feature that core location provides is the ability to geocode, which is the so for computers like location data in terms of latitude and longitude, because that's two numbers that's very easy for computers to store. It's not very intuitive for humans. We like things like street addresses. So geocoding is the translation back and forth between coordinates and user-friendly place marks, as Apple calls them. And there's support for both directions. Since iOS 4.1, in fact, you can. So there's two ways to do reverse geocoding, and that's taking a a location and translating that back into a human-friendly format like a street address. Since iOS 4, this has been used with a class built into MapKit, MK Reverse Geocoder. Since iOS 5, the preferred geocoder was moved into core location. I believe MK Reverse Geocoder is actually deprecated since iOS 5. So if you're targeting iOS 5, they recommend using CL Geocoder instead. They have essentially the same functionality, but that one's preferred. So these are really easy to use. You make a geocoder, you give it a coordinate, you let it kind of in the background determine what the location is, and then you'll be able to query that object once it's done for the human readable information about that location. Had something I wanted to say. Obviously, you need network access to do this. So if you're trying to do this without, you can get location data without the internet because the device has a GPS built in. But if you want to actually geocode, you need the internet. So this requires network access in order to do this, because this is all done back on, I would imagine, Google servers. But that might change since Apple recently bought a map company, and since Google is going to start charging people for their services. Okay, so since iOS 5, you can also do forward geocoding, which is translations of human readable addresses back into coordinates. And again, you use CL Geocoder for that. Any questions about core location before I go on to maps? Okay. So, maps on iOS are pretty much done through, there's one class, MK Map View, which gives you a map view. As you'll see I have a demo, this is going to be incredibly simple, just like what WebKit was. It's a fully functional map view. It supports panning and zooming, which can be disabled if you want, based on, there's just a property for zoom enabled and pan enabled, which you can control, so that way, if you don't want the user to be able to zoom, if you don't want them to be able to pan, you can disable those. So by default, if you just throw a map onto the application, it will just show you basically the entire world, which is probably not what you want. So a map has the ability to there's a property called region that allows you to define what part of the world I want to see, and the way you define that is you have a latitude longitude coordinate that you want to be at the center of the region I'm showing, and then what they call a span, which is it's a pair of degrees latitude and degrees longitude for how many degrees you want to show in latitude and longitude. So you basically, the idea is you say which latitude longitude point you want to be the center, and then how many degrees latitude tall and how many degrees longitude wide you want to show.
Is the span ever different? Because I don't think I've ever seen like a map that's not.
Yeah, I believe it will always make it. It will always force it to be square, but the way the span is used to set the zoom level.
Oh, okay.
So if you want to show the entire world, you'd set the span to be 180 degrees or something, so that way you could I guess 360 for the entire world, right? But if you want just like the Bay Area, you might say 2 degrees or 1 degree for the span, and then yeah, I actually haven't tried like doing non-square spans and seeing what it does. I imagine it just forces it to be square anyway. Okay, so one nice thing about maps is that they have built-in support for showing the user's location, and you just tell the property show the user's location. Yes, done. And then it puts that blue little dancing pin with the expanding circles to show where the user currently is on the map. So let's do that. No. Okay, time to make a really simple maps app. I call it Maps. All right, I'm going to go into my nib file here for this view. I'm going to grab a map view, drop it into the screen, and go. And hopefully the simulator doesn't take forever to launch, like it usually does. Take your time. Oh, what's your problem? Oh, I have to link against MapKit. God, I do that every time. Yeah, if you don't link your project against the MapKit framework, then you can't have maps. I don't know why I never... Okay. That might be more effective. Yay, we have a map. And... so I don't know I don't know if I've shown you guys this before, but if the simulator does have support for zooming, and the way you do this is you hold down the Option key, and then you get 2 cursors that spin around the center. If you want the position to lock, you can then hold down the Shift key, and then they'll move together. If you then release the Shift key, then they'll pivot around the new center point. So this is how you zoom. So now if I actually click and zoom, I can zoom out, zoom in, right in the simulator.
Is there a reason they don't just like integrate some multi-trackpad?
I guess they wanted to make it as general as possible. So because they don't want to assume that you're using a trackpad. Okay, so that's a really simple map. Let's have the map show where the user is. So in our view controller, I'm going to include MapKit. I'm going to create a reference to that map, which is an MK map view. One neat feature about Xcode that I just recently discovered is notice how this is an outlet and there's this little circle in the gutter. that's empty, saying that this outlet has not been connected. And if we now connect that outlet, it will update to show that it has been connected. So we just connect that to that map view, and now it will say, hey, it's been connected.
Wow.
Which is kind of nice. Okay, so now to have that show the user's location, I'm going to get rid of all of that because I don't need it except for view to load. All right, after the map loads, I'm just going to say map view shows user location equals yes. And then what's the other thing? It's okay, so let's just start with that. Bing, there I am. Well, you'll see it's not actually where I am because the it says I'm at Apple. One neat thing about the simulator is that if you go into the debug menu, it has this location menu for you to be able to set your current location. So you can give it a custom location of latitude, longitude coordinates. I believe these are the coordinates for New York City. Yes. So you can actually simulate location using the simulator. Unfortunately, the simulator can't use Wi-Fi assisted location to figure out where because your Mac knows where it is, but that feature isn't available to the simulator for whatever reason.
So what's like, right? Is it like a movie?
I don't know what these. I've tried these. They don't seem to. I wasn't quite sure what they did. I tried them and they don't seem to do much of anything. To be honest.
Maybe to wait a while.
I'm not sure. Okay, so one thing to notice is that it shows us the user's location, but it doesn't like auto zoom to where they were, which would be kind of nice. Surprise, you can do that. The map view has, what is that property? A property user tracking mode. This is the three tracking modes that you'll see in the Maps app, where you can just not track the location at all. You can track to the location, or you can track to the location plus their heading, and it will spin the map. Which there's no heading on the simulator, so we won't get to see that. But what is it? MK. What's the type of that? MK user tracking mode, obviously. Okay, so tracking mode follow with heading or none. So if we say follow, then it will center the user's location on the map and put it at an appropriate zoom level. Apparently that's where I am in New York. If I then change the location to Apple, does it fix itself? Yes, it does. There we go. Here's my office. Okay, so you can do so with like very much like with WebKit, with very little work, you can embed a map into your application. You're probably wanting to know, how do I put more information onto the map? Because right now, just having a map isn't super useful. What you usually want to convey something about some location or some region on a map. And the way you do that is using annotations, which is a way for you to draw really anything you want on a map and tie it to a location on the map. So a map view is, of course, a view, so it can contain subviews. The problem, though, is that subviews don't stick to a location on the map based on the coordinates. They'll just, if you pan the map, those subviews don't pan, which is probably not the behavior you intended when adding a subview to a map view. Instead, annotations work basically like subviews, where they're kind of a subview of the map, but they are attached to a coordinate, and then therefore they move with the map as the map zooms and pans. And so annotations are meant for highlighting a particular location. The Maps app uses pins to show locations of things, and that's actually a free annotation that Apple provides for you if you want to use those. You can also make custom annotations, and I'll talk about that in a little bit. It also has support for what they call overlays, which are geometric shapes that you can define to show larger regions, like parks or states or countries. And you can overlay those onto the map, and again, they'll move with the map. So a basic annotation, as Apple puts it, offers a way to highlight specific coordinates on the map and possibly provide additional information about them. So an annotation consists of an image drawn on the map with an optional callout button. And these callout bubbles provide a space for a button on the right-hand side if you want to be able to put more information or a link to some other page for more information about that annotation. Okay, so putting annotations on maps are a little bit sophisticated, but I hope I can explain how it works. It took me a while to figure out how it worked, actually. It was kind of magic at first. Then I realized I was doing it wrong, and I don't know how it works in the first place. So there are two things you need to put an annotation on a map. The first you need is an annotation object, which is this object that conforms to the protocol MK annotation, which is incredibly simple. It has a setter and a getter for coordinate. I think it has a getter for the coordinate, which is that CO location 2D. It's a location on the map, and a title. That's the entire protocol. And then you need an annotation view, which is the view that will actually get put onto the map. Somewhat oddly, you don't add annotation views to the map directly. You add annotation objects and attach those to locations, and then the map view will ask its delegate for the annotation view that matches with that annotation object. Does that make sense? And don't worry, I'll show you this in a second. So these are 4 steps directly from Apple of how to add an annotation object. The first thing you need to do is you need to define your annotation object. If your annotation is not super sophisticated, you can just use or subclass MK Annotation, which is a class that has a coordinate, and that's pretty much it. And you can set a title as well, or you can have some custom object that, as long as it conforms to the protocol MK Annotation, can be treated as an annotation object. Generally speaking, these should be pretty small. There shouldn't be too much data in an MK annotation, and you should be able to make a whole bunch of them really quickly. Because potentially you can imagine having a really large number of annotations on your map, and so each of these annotation objects should be fairly small. Next, we define an annotation view. Again, Apple provides some easy ones for you. There is a pin annotation view if you don't want to create your own image and all that. The other way to do it is to create a basic MK annotation view and set the image yourself if you have some custom image you want to use. If you want something more sophisticated, you can subclass MK annotation view and provide your own drawing code. If you want to do your own draw rect for that view, you can do it that way as well. Then there is a delegate protocol in MK MapView delegate that is MapView view for annotation, which, given an annotation, asks you for an annotation view for that annotation. And then finally, once you are ready, you tell the map you add an annotation or a list of annotations to the map view. And then the delegate will go fire off, and as it needs them, asks you for map views for the annotations that you've added. Okay, so let's do that. So I'm going to subvert the map's free user location, and I'm going to do it myself using core location. And let's see if I can remember how to do this. All right, so I need to include core location. I'm going to give my controller class a core location manager. I'm going to go back to my slides and steal that code for starting it. I'm gonna use the standard location service just because I'd found that the simulator doesn't respond well to the significant change location service. Because I imagine if you change the location of the simulator, it doesn't go through the intervening space, so that probably doesn't trigger the significant change location service correctly. So I'm gonna use the standard one, so that way I can just arbitrarily change the location of the simulator and get that and be guaranteed of getting that location change. Okay, so I'm going to add this method, which is going to start doing standard updates. You'll see that I need to implement the protocol CL location manager delegate. So let's do that. And then after we're done loading, I'm going to tell myself to start standard updates. Okay, so let's implement location manager did update to location. So this is going to get called every time the location changes. Okay, so just so we can see what we get from the CO location, let's just log out the new location. so small. Oh, why are you fail? Oh, I'm not linking you against core location, am I? You'll find that you'll do that a lot when you are linking against external additional frameworks, is that you forget to link against those when you build it, and then you get weird compilation errors. Okay, so we are given the coordinate plus 37, minus 122, plus or minus 5 meters. I'm not moving, and my direction is -1, whatever that happens to mean, and this is the time that it got that. Now, if I change the simulator's location to New York, I get another location update saying that I moved. I moved rather a lot, in fact. Okay. So that's that. We're not really doing anything with it yet, but it's a start at least. Why did that not? Oh, there it is. Took a second. Oh, weird. It moved. How did it move? Okay. That was mysterious. Okay, so let's go through those steps so that I can remember what the steps are. Where are those steps at? Okay, so the first thing we're going to do... Oh, get out of here. The first thing we're going to do is we're going to create an annotation object. For this, in this case, I'm just going to create one for the user's location. So inside of our view.did_load, after we start the update server, let's create a point annotation, user location. I hope I don't forget how to do this. I had this demo working before, so I know. Anyway, okay. So then I'm just going to tell the map. I'm going to add this annotation to the map view, and then I can safely release it because the map view will retain it. Oh wait, I have arc turned on. Okay, no worries. Actually, I don't. For the second part of my demo, I don't want to turn arc on. So hang on. Actually, I should check that that's actually saved to release there. I'm not entirely certain. I have to assume that it's safe, that it will retain it, but yeah, the map view retains the object. Okay, good. Okay, so now every time we get a location update from core location, we want to update the location coordinate of this annotation that we created, which is why that needs to be an instance variable. That's what I'm doing different that I got confused by. Okay, that makes sense. Okay, so I'm going to keep that annotation around, so that way when we get location changes, I can... So there's a coordinate property. I can ask a location for a coordinate property as well. And so now every time I get a location update, the coordinate of the annotation will change. Assume me, I'm leaking memory. Okay, now what do we need to do? Now what we need to do is there is a protocol for MKMapView delegate. So the other thing I'm going to do is I'm going to tell the map view that I'm going to be its delegate. And the method I'm interested in is mk annotation view. Please autocomplete. Thank you. View for annotation. So it's going to pass in an annotation object, and it's going to ask for an annotation view. Interestingly, the map auto-generates an annotation for the user's location. So in this case, since I don't want to do it twice, I'm going to check if it's that one, and then if it is, return nothing. So the way we can do that is we can ask annotation is kind of class. Hope I can remember what the class is. what is it? It's MK user location class, which is a special annotation for the user's location, since it's going to auto-generate one, but I want to use the one that I'm getting from core location. I'm going to return nil in this case, so that way I don't have two. Okay, now that we know that we're the this user location, this annotation, we need to generate an annotation view for that annotation. So we're going to make a pin annotation, because those are easy. Okay, so the initializer we want here is init with annotation reuse identifier. So the annotation we're going to use, surprisingly, is user location. And I'm going to create a string here for the reuse identifier. If you remember back when we talked about table views, is that table views cells, when they get thrown off the screen, go into a reuse queue, so that way you can just, without having to create a new table view cell, you can just grab one that's flown off screen. Apple has done a similar thing with annotation views, so that way we can, but if we want to potentially throw a lot of annotation views on screen at once, and as we're panning around, it's silly to keep the ones that have gone off screen in memory, so we should be able to recycle those for another annotation. So there is a reuse queue. No, actually, this isn't what I want at all. Hang on. I want to MKN. What is it? Oh no, sorry. It's So okay, so like that. I'll need that later. But actually, I'm gonna keep that. Okay, so let's just call this pin or something. So that will create will create a new one with that pin identifier. But let's. This is gonna seem kind of dumb in this example where there's only one annotation view anyway, but it's useful to know how to do. So before we actually go about and allocate and initialize one, let's check. We want to first check if there is one available in the reuse queue. So the way we'll do that is we'll ask the map view for it. So in this case, that's going to give me a warning that it's scoping because it's the same as my instance variable. So I'm going to use that one. Not super important. So there's a method DQ reusable annotation view with identifier, which grabs if there's an annotation view in the queue available, it grabs it and returns that. All right, and it's complaining that that's because this is going to return just a superclass of annotation view. I want it to be a pin, so I'm going to cast it. Oh, I love code wrapping in a small window. Okay, so then if the pin view comes back null or nil, meaning that there isn't one available in the reuse queue, then we want to actually make one. And regardless, we want to return whatever the pin view happens to be. Okay, so we can do some customization on this pin view. We can say pin view, what is it, pin color. So there are annotation, pin, no. Okay, pin annotation. There are 3 default colors, green, purple, and red. Let's go with green, just for fun. So one nice thing about annotation views is they also have the ability to have a that little call-out bubble, which I can set the. No, I can't set the title of it, but it will actually grab that title from the annotation. So if I want a title to show up on that call-out bubble, I'll actually set that on the annotation. So I can say title is, I don't know, you are here. I feel like I'm missing something, but let's see if that works. I really feel like I'm missing something, but it's the other one. Okay, small thing. It's when you do this kind of recycling pattern, it's pretty common to auto release that, so that way it get the memory management of that is taken care of for you, so you don't have to worry about it. If you ever look at the stub code that's provided with a table view, it does almost this exact same thing, but with table view cells instead of annotation views. Please work. Okay, so there's a pin. It doesn't zoom though, so but we can take care of that. Oh, I'm so glad that worked. Okay, so we can do one additional thing when we get a location change, and that's set the region, reassign the region on this map. So let's tell the map view, we'll give it a new region. So you notice that the type of that is MK coordinate region, which is just a struct. So there's a C function to make one. MK coordinate region make. You give it a location coordinate, which we have, so we can just ask for the new location for its coordinate. Then we need to make a span. I'm just going to pick a span of 1 degree of latitude and 1 degree of longitude. So I'm going to do MK coordinate span make with 1 and 1. And that will update the visible region of the map to be this region. There we go. One other nice thing that we can do with the pin that I forgot about is you can have it animate being dropped, which is just a nice little property, animates drop. So when it appears, it should kind of plop down. Do that neat little animation that Apple made. And I think it'll do that again if I move. Maybe not. Okay. But again, we're still catching those location changes, and that annotation is being reassigned, and MapKit handles all that for you, which is pretty cool. So I'll post that up on the website after the lecture. Okay, so what did I have left?
So is there a way to define your own custom annotation view with its own custom animation as well?
Probably. I don't know how to hook into when you get dropped, because that'd be how you do the animation. You might be able to do something clever like on view will appear to animate yourself in. But yeah, you can just do a custom subclass of annotation view to make your own custom annotations and do your own drawing code if you want, or do your own, have your own subview hierarchy for drawing into that. You should be able, in theory, you should be able to do that. The animation of the drop might be tricky, but I think if you do something on view will appear, that might be able to work. Okay, so you can also, like I said, you can also have overlays to maps, which are rather similar to annotations, but rather more complicated, so I'm not going to talk about them. The documentation explains pretty well how to make them. The basic idea is that rather than specifying a point for the annotation, you specify the corners of a polygon or the center of a circle and the radius of a circle, and then overlays are treated as subclasses of annotation, so they work like annotations, but they're just more complicated. Okay, so that's all I have on MapKit and core location. Any questions? Here's some resources. There's a really great guide called the Location Awareness Guide, which they use to, if you want your application to know about the user's location and you be able to use that, this is a really great starting guide to kind of give you the basics of how to use core location, how to put maps in there. You'll notice that this lecture is pretty much just echoing that. If you want more detailed reference for each of the different frameworks, there's one for core location and one for MapKit as well. Any other questions? Cool. All right, I'll have that code up in a little bit so that way you guys can take a look at it and play with.